Hello guys, well now we're gonna do problem 14.21, and this is a problem that we have. This is a very long problem. You can read the questions right here. What I did was to write the original equation, and then that way I could find what the information is given right here. The first part is asking for the period. So this is the equation that I use, 2 pi divided by the angular velocity. We plug in numbers and we get that the period is 1.51 seconds. For part B, the force constant of the spring, I have this right here. The equation that I use is this right here. It comes from this original equation of the angular velocity. So we solve for the constant of k and we get 29.4. To find the maximum velocity, this is the equation that I use, amplitude times the angular velocity, and I got 0.308 meters per second. To find the maximum force, we use this equation right here, and we can substitute acceleration with the amplitude times the angular velocity square. We finally get a maximum force of 2.18 newtons. To find the distance at a specific time, we just plug in the given time, in this case is 1, and we plug it into the equation. The position is negative 0.0125 meters. For the velocity at 1, we do the same. We plug in the numbers after taking the derivative, and we get 0.303 meters per second. The answer gives us a negative number, but since we're trying to find the magnitude of the velocity, it's actually a positive number after putting the absolute values. For the acceleration, same case. We use that formula after taking the derivative, and we get 2.16 absolute value, and it's 2.16 meters per second square. Finally, for part H, we're trying to find the force. And since we already found acceleration, we use this original formula and we get 0.367 newtons.